Why so many corporate AI projects fail? Executive summary. Many corporate AI initiatives fail despite heavy investment. Projects often stumble due to unrealistic expectations, biased or low-quality data, weak integration, and poor alignment with business goals. High-profile cases like IBM Watson for oncology, Amazon's hiring tool, and Microsoft's Tay illustrate recurring flaws: over-reliance on technology, lack of domain expertise, and insufficient ethical safeguards. Most AI pilots never scale because of data readiness gaps, organizational resistance, and immature infrastructure. True success requires linking AI to clear outcomes, ensuring data quality, involving experts, prioritizing transparency, and managing adoption. Ultimately, effective AI depends on alignment between technology, business, and people. Artificial Intelligence, AI, continues to promise transformative change for business, but the reality has been far more uneven. Across industries, from finance and healthcare to retail and logistics, corporations have launched ambitious AI projects that ultimately fell short of expectations or were abandoned altogether. Despite massive investment, studies consistently show that the majority of enterprise AI initiatives never make it past the pilot phase or fail to generate measurable business value. Below is a detailed look at the kinds of AI projects corporations pursue unsuccessfully, illustrated through real-world examples and an exploration of the deeper organizational and technical causes behind these failures. 1. Overambitious magic bullet. Systems in complex domains. One of the most common pitfalls occurs when companies believe AI can instantly master a complex human domain, medicine, law, or strategic management, without understanding the underlying nuance and data challenges. A prime example is IBM Watson for oncology, a project launched with great fanfare. IBM promised that Watson's natural language capabilities could analyze medical literature and patient data to suggest personalized cancer treatments. In practice, however, hospitals found the recommendations unreliable or impractical. Many oncologists concluded that Watson's advice reflected training bias. It had been trained primarily on data from a few U.S. institutions and couldn't adapt to new clinical contexts. By 2021, IBM had quietly wound down the initiative after hundreds of millions of dollars in investment. The failure underscores a recurring lesson. AI is not a replacement for domain expertise. In high-stakes sectors like healthcare, small data quality issues can lead to catastrophic errors. Successful systems must be co-designed with domain specialists, not dropped in as a one-size-fits-all product. 2. Biased and unethical decision-making systems. AI's dependence on historical data can inadvertently amplify social and organizational biases. Companies that deploy algorithms without addressing these biases often encounter both ethical backlash and operational failure. Amazon's now infamous AI hiring tool is one example. Trained on past hiring data, the system learned to downrank resumes containing words like women's, effectively discriminating against female applicants. This wasn't because the algorithm was malicious. It was simply replicating patterns in the data, which reflected a male-dominated tech workforce. Amazon scrapped the project once the bias became public. These failures reveal a deeper structural problem. Many corporations rush to automate processes before ensuring their data governance and fairness frameworks are sound. Without explicit fairness objectives and human oversight, machine learning systems will reproduce and often amplify existing inequities. 3. Chatbots and conversational AI gone wrong. Chatbots are among the most visible corporate AI efforts, and they also provide some of the most public failures. In theory, conversational AI can reduce customer service costs and improve engagement. In reality, it often proves brittle when exposed to real-world users. The classic example is Microsoft's Tay, a Twitter chatbot designed to learn conversational patterns from interactions. Within 24 hours, internet trolls had trained it to generate offensive, racist, and sexist content. Microsoft shut Tay down in less than a day, but not before the damage to its reputation was done. Even modern successors, such as customer service bots deployed by airlines, telecom companies, and banks, struggle with contextual understanding and empathy, producing robotic or inappropriate responses. Many companies underestimate the difficulty of natural language robustness, which requires large, clean conversational datasets and sophisticated guardrails against manipulation. 4. AI that never escapes the pilot stage. Perhaps the most widespread failure pattern is not catastrophic error, but quiet stagnation. Research from McKinsey and Rand indicates that 70 to 80% of enterprise AI projects never reach production. Companies often pilot machine learning models successfully in controlled environments, but scaling them to production, integrating with IT systems, ensuring data pipelines remain consistent, and retraining models as conditions change proves far harder. Consider a retailer attempting to implement AI demand forecasting. The prototype may work in one region using clean, historical data. Yet when rolled out globally, inconsistent point-of-sale systems, missing data, and legacy IT infrastructure cripple performance. The issue isn't the algorithm, it's the ecosystem. This pilot purgatory reflects a broader maturity gap. Many firms invest in data science talent, but neglect the data engineering and change management layers necessary for operational success. 5. Generative AI without a clear business use case. The 2023 to 2025 generative AI boom has triggered thousands of corporate experiments: automated content creation, coding assistants, marketing copy generators, and internal knowledge bots. Yet research from MIT and S&P Global suggests that up to 95% of generative AI initiatives deliver no measurable return on investment. Why? In many cases, these projects are launched to signal innovation rather than to solve a pressing business problem. For instance, marketing departments deploy AI to produce synthetic ads or social media posts, but without tracking conversion or brand impact. Legal teams use large language models to draft contracts, but cannot validate accuracy or compliance at scale. The result is what analysts call AI theater, projects that demonstrate technical capability but fail to align with core business outcomes. Effective generative AI adoption requires more than a proof of concept. It demands integration into workflows, retraining of staff, and clear performance metrics tied to productivity or revenue. 6. Autonomous and predictive systems that misfire. Another recurrent failure involves predictive or autonomous systems in logistics, finance, or manufacturing that behave unpredictably when confronted with rare or changing conditions. For example, several financial institutions have abandoned AI-based credit scoring systems after discovering unintentional discrimination or erratic risk predictions during economic downturns. Similarly, some autonomous vehicle pilots have been paused following safety incidents that exposed gaps in sensor fusion or edge case training. These failures highlight a persistent challenge. AI models perform well within their training distribution, but break down under novel circumstances. Robust validation, continual monitoring, and explainability tools are essential to prevent such drift. Yet many organizations treat model deployment as a one-off event rather than an ongoing life cycle. 7. Common root causes across failures. Despite the diversity of examples, failed corporate AI projects share a set of recurring root causes. Strategic misalignment. Executives often treat AI as an IT project rather than a business transformation. Without a clear link between AI outputs and measurable outcomes, such as cost reduction, revenue growth, or customer satisfaction, projects lose sponsorship once budgets tighten. Data readiness gaps. Many firms underestimate the effort required to clean, standardize, and govern data. Poor quality data leads to unreliable models and erodes trust among business users. Organizational resistance and lack of change management. Even when models work, employees may resist adopting them, fearing job displacement or distrusting algorithmic decisions. Training and transparent communication are critical to overcome this barrier. Ethical, legal, and reputational risks. Projects that ignore fairness, privacy, or transparency often generate backlash from regulators, customers, or employees. These risks can outweigh any operational gains. Overhyped expectations. Executives sometimes believe AI can be plugged in to instantly deliver insights. When reality proves slower and costlier, enthusiasm fades and funding evaporates. Failure to integrate and scale. A working prototype in Python is easy. Deploying it securely, maintaining it, and integrating it with legacy systems are not. Without mature MLOps pipelines and cross-functional coordination, models stagnate. 8. Lessons learned from high-profile failures. From these stories, several key lessons emerge for future AI success. 1. Start with a business problem, not a technology trend. Define success metrics up front, profitability, customer satisfaction, or risk reduction, and design the AI system around them. 2. Invest in data quality and infrastructure. Reliable, well-labeled data is more valuable than any fancy model architecture. 3. Embed domain experts throughout development. Collaboration between technologists and subject matter experts ensures relevance and accountability. 4. Prioritize transparency and ethics. Explainable AI, audit trails, and fairness assessments reduce the risk of hidden bias and regulatory blowback. 5. Plan for change management and adoption. AI succeeds only when human users trust and use it. Communication, training, and user feedback loops are essential. 6. Treat AI as an ongoing capability, not a one-off project. Continuous monitoring, retraining, and governance keep models relevant as conditions evolve. 9. The path forward. The failure of so many corporate AI projects should not be seen as proof that AI lacks value. It highlights the growing pains of a transformative technology. The organizations that succeed are those that approach AI with discipline, humility, and a systems mindset. They understand that AI is not magic, but an evolving toolkit requiring careful integration into business processes, data ecosystems, and human workflows. In short, AI project success depends less on algorithms than on alignment. Alignment between data and decision, between model and mission, and between innovation and implementation.